Welcome to my talk about complex event flows in distributed systems. I actually threw out a lot of customer assignments. I went through the last couple of months or years even. I saw that, with all the hype we currently have with microservices, with probably DDD, with reactive programming, with a lot of these different things currently coming together, I saw a couple of things that are happening at our customers, which basically boil down to three hypotheses which are currently applied in most of the projects, at least if they want to be hip or modern. So one is that there's a current belief in event-driven architecture, which I think is a good thing. I come back to that. But there's a big belief that events really decrease coupling all of the time. And that's one of the hypotheses I want to check today. I want to also check that probably orchestration should be avoided in favor of choreography. If you're not really aware of what's choreography and orchestration, I will come back to that later in the talk. And I also want to look at something which I really see a lot out there, that workflow engines or orchestration engines or BPM, whatever you want to call that, that's really like from the past, that's painful, that's nothing you should use. As always, I'm opinionated, as like I think like every human. I want to just make it transparent. So what's my personal background? My name is Bernd Rücker. I'm one of the co-founders of Camunda. We're a relatively small company. We're 100 people based in Germany. We're doing an open source workflow automation tool. So that basically means I'm in that workflow automation space, in that state machine space for like 10 to 15 years by now, working for customers all over different industries, different sizes, so we're quite successful there. We will probably run short in time at the very end of this talk, so if you have any questions, either approach me later on here, or here's my email handle, my Twitter handle. Feel free to ask me anything there. So let's get started. And I like doing examples, and I have one example here today, which is basically, I would say, inspired by Zalando. Zalando is one of our customers. You probably know Zalando. They're shipping clothes to a lot of companies by now. They're relatively big, and they obviously have an order fulfillment process. And as I cannot go into all the details of what Zalando is doing, I basically made my own example, which is a bit simplified, and I made the example of the Amazon dash button. I'm not sure if you know the dash button. So the idea is that you just click the dash button, and then something is ordered, which is hard-coded basically in the dash button. So it could be like washing powder. You put it next to the washing machine. Washing powder is empty. You just press the button, and then something is delivered to your house. And in the background, that's kind of a, let's say, business process which has to be executed. So you probably have to pay for what you want to get. It has to be fetched from the warehouse, and it has to be shipped to your house. And that's kind of the thing we want to implement. And if we do that, if you're into DDD, domain-driven design, I think we have a talk on that later on, which could be probably very interesting, like how to find these kind of boundaries. So how to identify really components you want to use in order to do that. But that's not my focus today. But I could imagine that we have a checkout like context where everything is done with the dash button. Then we have obviously something to pay, something to manage the inventory, and something to ship. And if you're into microservices, that might also be like your microservices. For me personally, the important thing about microservices, and I come back to that later on, that's why it's important, is that it's very much about autonomy. So if I have these different services, what I try to do is that they are all very autonomous. They have their own development team. They probably have their own data store. They probably run on their own, nowadays you don't run on hardware anymore, but their own virtual servers or Docker containers or whatever it is, but it's a separate process. You're not running on like in the same, probably even a different programming language. And that's really like very distributed components you have. So that's setting the scene. That's what we have. And now, if we look into how these different components should form that overall business process of delivering a custom order, we could first of all look into event-driven architectures, because event-driven is quite hip at the moment. So let's look at an example first. So what's event-driven? What's the difference there? So you could have a requirement that you say, okay, the dash button that blinks green if everything is on stock, that you get the order shipped right away. it's not possible with the dash button, but we could imagine such a thing. And in order to implement that, let's say the naive approach would be something like, okay, the checkout component makes the button blink, but it has no knowledge about the goods in stock. So it basically could ask the inventory, because the inventory has the knowledge what's on stock or not. And then you basically have this kind of request response going on. That's like what we did, like not event-driven, what we do for ages, which is normally very intuitively understandable. That has a couple of downsides. So if the inventory is not available, you have no idea if something is on stock or not. So you couple that together in a way, even like temporal for availability and a couple of other things. What's the alternative? And that's for probably even for somebody that's pretty new as well. But that's the event-driven approach, and the event-driven approach would make it very different. So in that case, I would do something like the inventory still has the knowledge, but whenever something changes, like I get new goods on stock or I booked something out, I send an event to the world. It's kind of a broadcast. I have no idea who is interested in that, but the checkout component could decide, oh, I'm interested in that, fetches all the events, reads them, and build its own local like read model. Like it's kind of a cache, if you want to say it like that, but it now has own local data in order to answer the question if it should blink or not. And that decouples the components in a way that, at least temporarily, and you could easily like build that on top without changing the inventory service. So that's probably a very good idea to do. So that's a good example of using event-driven architectures. There's some value in that. The thing is that when you get into these kind of architectures, that a lot of people like, now you have that golden hammer, so let's use that for everything. And what I see a lot happening out there is that this is now also used in order to implement these business processes. So if you think of that, like we have to pay the item to fetch and to ship, how could that work like in an event-driven world? So checkout probably, whenever you press the button, could say something, okay, there's an event order placed, I send it to the world. Payment knows, oh, hey, there was an order placed, I have to retrieve some money. And then when I retrieve the money, I probably issue another event, hey, payment received. Inventory knows, oh, that's for me. Does whatever it has to do, then it basically sends another event, hey, the goods are fetched. And shipment knows, okay, now I have to ship the goods, and then probably that's done. That will work, actually. That will work. Technically, it's possible. And I actually saw that also on a big scale. So I saw customers doing that with like 100, 150 services and a lot of events actually circling around. The problem, I think it's very obvious if you draw it like that. The problem is that you really don't see that flow anymore. So it's kind of a slippery ground because you lose the overview of what's going on in the architecture. I discussed that really often actually over the last years, and I was so happy as as I read a blog post from Martin Fowler. You probably know Martin Fowler. He's quite famous, and he also did a lot of talks on event-driven architectures. He's obviously a fan of event-driven architectures. But early 2017, he wrote something like this. Okay, the danger is that it's very easy to make nicely decoupled systems with event notification. That's why we're doing it, actually. But without realizing that you're losing sight of a larger scale flow, and thus set yourself up in trouble for future years. And that's not where you want to be in future years, obviously. And I was really happy to see that, because that's what I observed in a lot of customer projects as well. And you can make easy examples. So let's assume we want to change just the sequence of steps. So let's assume we want to fetch the items before we do the payment, because probably we want to ship fast, or we want to reserve the goods for the customer. There are a couple of possible reasons to do that. And if we want to do that, actually just changing that order here, we have to adjust, and I really like that effect. We have to adjust a couple of services at once. So we basically now have the inventory has to listen to the order placed event, and then the payment now has to listen to the goods fetched event, and the shipment service has to listen to the payment received event. So you basically change all the three services down there. So that's quite a lot, actually. That's bad. And the worst thing actually is that not only you have to have these changes, you have to deploy them at the same time, because you probably and you have like running orders in your current system. So normally something is circulating around with certain events currently, and it's really hard to make that change because you don't have that one moment in time where everything is stopped. And you also have to coordinate the teams which basically build the different microservices. And actually that's for me, that's a very important thing actually. So I always use that metaphor as the core promise of microservices. And I learned that from Eric Evans, by the way. That's the guy who wrote that DDD book, who started all the DDD stuff. And that's the three-legged race. So the people are bound together by their feet, and then they run. And what's very obvious by looking at the picture is that they run slower than if they would run alone. And the risk of falling down is much higher because you probably just, it's not that easy. And that's what we do in companies all the time. We bind different teams together. They have to coordinate, to sync in order to do a deployment. Probably like in the old days, we did that with the whole company and said, okay, there's one deployment a year or something like that. I still know customers doing that. So that's exactly what you want to change with microservices. You want to have the teams running on itself as fast as they can, and that you basically make impossible by these kind of changes here. So that's really a problem with these kind of event-driven peer-to-peer event chains here. I once made this picture for that, actually, because I discuss it really often. And that's the typical picture you see whenever somebody basically explains choreography to you. And choreography is the thing of that, what we just saw with the event-driven thing, that they're just talking to each other and somehow the process emerges without somebody controlling it. And the picture is always this, like, okay, there's these like ballet or whatever it is, and something beautiful emerges out there without anybody really controlling it. And actually, I don't think that metaphor fits that well. So what I see out there, the customers, is a bit different. Is that everybody is doing something, yes, but somehow you lose control. It's really hard to manage. It's sometimes even hard to understand what flow is going on in order to produce a result. So that's quite a thing currently. So I think that's one of the big problems we have there. We did a survey earlier this year. There's a URL up there, so you can download that survey. And we asked a couple of things. And one of the questions was also for the challenges projects face which go into microservice direction. And the top two answers, I only want to read through the top two answers, are lack of visibility into end-to-end business processes. Okay, that's exactly what I said here. And ambiguous error handling leading to antitrust errors at the boundaries between microservices. So that's actually the thing. As soon as we start to separate logic into different components, into different microservices, the single microservices gets typically easier to do. But the challenge is to make them do something useful in combination. Okay. So what would be a different approach here? So a different approach would be, first of all, to extract that logic, that business capability of the order fulfillment. Especially if you think of something like Zalando, it's very obvious that their business case, the one most important business process, should be probably an own service, like the order service in this case. And then you change a couple of things. So first of all, you would probably, the animation is a bit broken, that doesn't matter. We do it like this. So we would do it probably still like event-driven at the beginning. So order checkout could still do an order placed event. But then we have the order service, and that listens to order placed and says, okay, order placed, yeah, that's my turn. I start doing something, but then you also have some commanding infrastructure. You say, okay, the order now tells the payment service to do something. Hey, retrieve the payment for me, please. And then payment service at some point in time says, okay, there it is. There you have it. And then the order service decides what to do next. That's actually, in this example, it's a very natural thing to do. And then you start having that overview. Then you start having that moment where you can really dive into. That's a lot of people normally. A lot of people normally start. Already I'm thinking about, okay, this commanding thing, but is that really a good thing? And for me, there are two important things about that. The first is on this slide. So it's basically a decision in which direction you want to couple. So either, like in this case, the order service decides to listen to the order placed event. So the coupling is done on the recipient side. And in the other case, like order to payment, the order decides to send a command to the payment, so the coupling is on the sender side. It doesn't have to do anything to do with communication. It could still both be asynchronous. So it could be a message queue anyway. It doesn't have to be REST because it's like commanding. And these are some of the misconceptions I typically have in discussions. That's why I put it on this slide. And that makes you just have to decide for each of these communications, okay, where's the better place to do the coupling, either on the recipient side or the sender side. It's not always easy to decide that, but very often there's a natural place. And the important thing is that you really think about that. Like, it's not event-driven is always the best. Sometimes it's better, sometimes not. And that's a very conscious decision. And that's important to do. Okay, let's assume we do that. Let's assume we do these kind of commands, which I really recommend, which helps to reduce complexity in the architecture. Then normally commanding, like telling somebody else to do something, that's also orchestration from the term. Like choreography was the other thing with the I react on events, but orchestration is telling somebody else to do something. And actually, orchestration has a bad reputation. If you normally now, if you approach the enterprise architecture of your choice, basically all of them work normally. If you approach them and say something about orchestration, it's kind of, we had bad experience with orchestration in the past. So we had this kind of SOA thing, these ESBs, like these large, unhandy, huge things, very expensive, where a lot of logic actually went into the ESB because it was very smart about routing and probably even having like the order logic, the orchestration logic even embedded in the ESB, or there was ESB and BPM and these kind of things. And that actually turned out to not work very well because, first of all, you had like three rect laces again, because now you had very often a central component like the ESB or BPM. You had to talk to that team in order to do something. Even if you changed something on the left side, you couldn't just redeploy it because you had to change something in the BPMN as well. And then there were these very unhandy tools and so on and so forth. So there were really a lot of problems with this approach. That's why, again, Martin Fowler, which I quoted earlier on as well, he came up with these very, very famous quote where he talked about smart endpoints and dumb pipes. So the ESB shouldn't be magical. It shouldn't be very, very smart. It should be just a pipe like RabbitMQ, like Kafka, like whatever it is in your architecture, just a dumb transport. And then the logic should be in the services. That makes actually a lot of sense. But actually that's what I think we should do, and what I also propose with orchestration. Do the order service within an order service. It's not within the middleware, it's an own order service. So the orchestration is like a separate service. That makes a lot of sense. That doesn't violate that principle. Then you probably go along and you probably also read through a couple of materials, and then you probably see Sam Newman's book. Not sure if you know Sam Newman. He wrote that microservices book in O'Reilly, and he's quite famous by now. And he wrote something. I met him actually on Wednesday, and he knows that I really don't like these kind of things. It makes me discuss a lot. But he wrote something like, a few smart God services tell anemic CRUD services what to do. That's the risk if you do orchestration. So I put it in a picture. This is how it looks like. So, but the risk is that the order service grows big, consumes all the logic, and the payment is just like a CRUD service in order to store something. And if you do this, that's bad, obviously, because then too much logic is sucked into the order service, and that makes like the order service team like, yeah, doing too much, and then you probably also have to discuss everything with the order service. So that's bad. I totally agree that this is a bad idea to do. But this doesn't have to do anything with orchestration. It basically, from my perspective, it has to do with making a bad API. And I make an example, and again, I'm an example guy. We stick to the business example of order fulfillment. So let's assume the order at some point in time want to retrieve the money, the payment. We can very, very, very easily imagine that the order service says, okay, sends a command, retrieve the payment. Now, the payment service probably want to charge a credit card for that, right? That probably makes sense. You have, like in your Amazon profile, you have your credit card. Whenever you hit the dash button, your credit card is charged. Normally, credit card handling is a different service. And that's just, the payment just talks to the credit card. Now, let's assume the credit card is rejected for whatever reason. It's invalid, it's locked, it's expired, whatever. There is some reason why you cannot charge the credit card. So now, like a very, let's say, again, like a naive approach or a very, very spontaneous thing, what a lot of people but actually do is then, in this case, just rethrow that error from the payment service and say, oh, the credit card was rejected. And then it's a problem of the order service. And that's a bad API design. Because now you start making the order service thinking about details of credit cards. It shouldn't. It doesn't know about credit cards. It knows about payment. And so what you should do, and then you probably start having requirements like with that dash button. You probably want to charge the credit card. And if the credit card doesn't work, you want to send an email to the customer that says, okay, hey, we couldn't charge your credit card. Please go to your account details, update the credit card, and then we are happy to move on. And this is, for example, what GitHub is doing. They're sending you an email and says, hey, you have 2 weeks until we close down your GitHub account. And if you have these kind of requirements and you have this API design, you start implementing that in order. And that makes order bigger. That's a bad idea. But you should implement actually these kinds of requirements in payment. So actually the API should be something like, hey, payment, retrieve payment for me, and then I get back, like, let's say, an end result. Either, hey, the payment was there, or the payment didn't work. It failed, but it failed ultimately. There's no way of getting the money there. You have to cancel the order or something like that. And that's much better API design. The problem with that kind of thing is that now I have that the requirement of I'm giving the customer probably 2 weeks to update the credit card. And that involves state, that involves timing, and that involves something I normally call long-running services. I even call them potentially long-running because in the good case, they're normally like in milliseconds. But if there's something going wrong, they're probably waiting for like 2 weeks. And that definitely involves state handling. And that's very often the showstopper why projects are not going down that route. Because it's much easier to write like a stateless service than to have something stateful. That brings me to handling state. Handling state actually in 2018 shouldn't be such an issue actually. Probably with serverless it starts to get one again, but it's actually in most architectures very easy to have some, I start calling it persistent thing. So it could be whatever it is, like an entity, a database table, a persistent actor if you fancy it, or whatever it is, something in your environment which you can persist and then load again later on. The thing is, if you do this, you start having to add additional things in order to get going, like a scheduler. You probably have to retry, or you have to monitor the timeout for the 2 weeks until you raise the payment failed error, or other things. So a lot of people start sensing, if they think about this possibility, that there's quite a complexity involved. Also with the versioning I had earlier on, if I want to change the flow of events or the flow of commands, and I still have running things, how do I do that? Oh, that's not that easy. So there are a lot of problems you have to solve in that space. And that brings me basically to another hypothesis I wanted to check. So, I mean, there are tools out there which do exactly that, which are basically state machines. Most often they're called workflow engines, but they're essentially state machines, and they're exactly built to do this kind of thing. The problem is that in the most projects, when you approach them, and that actually happened to me for quite a while. So I do workflow engines for 15 years. I contributed to a couple of different open source workflow engines over the time. And always when I were, for example, at conferences and people ask me, hey, what are you doing? Then I normally say something, oh, we're doing workflow engine. And then it was like, ooh, I'm sorry for you. I was kind of, why? That's the coolest job ever. I love that. Where's the problem with that? And it took me actually a while to understand that. But it's not that hard to follow. But most developers think of workflow engine as very complex things like these BPMS from like 5 to 10 years ago, from the big vendors, very heavyweight on iron, meant to be like low code, so getting rid of the developer. Do I have the slide on that? Yeah. Like getting rid of the developer because the business people can click together their workflows on themselves. That was the promise for most of these tools, which is not a surprise that this doesn't work out. These tools normally end up at the developer. And the developers hate them because it's like really proprietary. It's what I call death by properties panel. So you cannot just copy and paste code like from you go on whatever. In the web, you search for something, find a solution, just copy and paste code. No, you have to follow like a YouTube tutorial in order to click through like their proprietary panels. That was a reality with most of the workflow engines. And that's why they have such a bad reputation. And very often also, like what Martin Fowler said earlier on, they were very central tools. So they were really like central in the organization. They were not agile. They were not microservice-based. So that was kind of a thing. But that changed a lot. If you look at the workflow engine market at the moment, it's actually quite interesting. There's a lot of things going on. So, for example, all the cloud vendors are doing something. So AWS, for example, Amazon is doing step functions if you're in Azure. Azure does durable functions, for example, which is kind of the same thing. And the others are also doing something. So these are, in its essence, it's a workflow engine, it's a state machine. Then we have like Silicon Valley companies doing a lot of things like, not on the slide, but Airbnb does Apache Airflow, or Uber does Cadence, or Netflix did Conductor, which are workflow engines. Rebuilt basically from scratch, very opinionated. So, for example, Uber is only in Go and Cassandra, so very narrow use cases from time to time. But it shows very clearly that the problem exists for all these kind of architectures. And then we have like a slew of open source ones there. What I said earlier, I'm involved in a couple of these. That depends very much on the language you're developing in. So for today, I have a Java example. I could also do like a C# example. So depending on the language, these behave a bit different. Approach me later on if you're interested in some details. I can basically also show you anything there. But they're all very lightweight. Some of them, that's what we're currently doing, and that's a very interesting project. It's our current R&D project, an open source project as well. As CBs there, we do an horizontally scalable workflow engine. So really, that can take basically any load. But that's not what I'm talking about today. I use another example, Camunda, also from coincidence, from the company I co-founded. But I just show a very quick overview of some code in order to get you an idea, to give you an idea what I mean by lightweight. And that's true for a couple of the other tools as well. So it's not bound to the certain tool, but this slide basically is all the code you need in a Java class in order to get a workflow engine running, deploy a model, and get it going. That's it. It's not much more. So I walk you quickly through it. So the first line here is like I configure and build a workflow engine in memory. I could have like options, like configuration options, but that's the simplest version. It's used in memory database. Okay, that's it. The next thing is I create a workflow model. In this case, it's like a very simple model. I could actually model it graphically if I prefer, but I normally start with the Java DSL, with the code example, because developers are often also afraid of these graphical things. That's why I start with code, actually. But it's the same thing. You can basically choose. So I have these two steps, which I do in a row. And then, that's BPMN. I come back to BPMN in a couple of minutes. It's an ISO standard. That's basically the important part here. So it's nothing proprietary. It's an ISO standard. It's very well adopted worldwide, so it's worth to have a look at. I definitely love the language, actually. Okay, I wrote a book on it, but because I love the language, not I now have to love it because I have that book. So it's the other way around. It's a really good one, and I give you a couple of examples in a minute. And then I can basically attach code. That depends on the language you're working in Java. That would be a way. I could just attach a Java class, and this is how the Java class is implemented. And then whenever you start a workflow instance like this, you run through the workflow instance, and then you follow the model, and whenever you walk through a certain node, you execute the code down there. So that's easy. That's it. It's very, very lightweight. It's nothing prepared, nothing heavyweight, nothing to be afraid of. And then the awesome thing is now you have a state machine. And these pictures are now BPMN. I explain a bit on the way. Does anybody know BPMN? Just to make sure I'm not explaining it. Okay, a couple of people. So this is how it looks like. So I could do something like, okay, I start there. The first thing I do is I charge the credit card. And then I'm done. Basically a very easy flow. But whenever I have a problem, I now probably inform the customer. And the next thing, I wait. And that's the state machine here. I can wait forever if I want, for ages. And I have the notion of time. Whenever that takes too long, I do something else, for example. That's very easy to do. You can just define it, deploy it, and the engine takes care of. Stateful, handle time, awesome. That actually gets very handy also for a lot of use cases in distributed systems, because if you say microservices or whatever you say nowadays, or serverless, normally it means you're in a distributed systems, and we start distributing the systems more and more. I use that metaphor for distributed systems, actually. I learned it from Jonas Bonnet, the Lightband guy, the Akka guy, and I think it's very well fitting. So that small hut there, this, for example, that's one program, one microservices. Yeah, there it's easy. You have one language, you probably have control over the threading, you probably have an asset transaction model. It's really nice and cozy in there, a heating, so it's cool to program in there. But whenever you open the door, there's a rough ocean, and that's the network. You probably know the fallacies of distributed computing from Peter Deutsch. The first one is the network is reliable. Of course, the network is not reliable. You can expect really bad things to happen there. Messages being lost, turned around, a lot of things will go wrong. And that poses a lot of challenges, and I think some of them you really need state in order to handle them properly. And I want to make an example again. So we go back to our order, payment, and credit card thing, and let's assume the payment service calls the credit card via REST. It's actually still what I see being used most out there, actually. And it would be very natural if you use something like Stripe or a provider which does that for you, then it's very often REST. And now let's assume you have a network error while calling the credit card payment service or the credit card service. The first thing is, if you have that problem, it's a network problem. Again, a natural, naive thing to do now is throwing that error to like the order service. But that would probably, again, making the order service bigger, like a God service, because it now has to think about, oh, what's happening there? Oh, there was a network error while talking to the credit card. We probably should retry it. It probably was a network hiccup or whatever. So you should do that differently. And one of the patterns which we use very often there is like a retry. A retry is very natural. I just retry it. That you can even do like very, very basic. Like there are a lot of frameworks which can immediately retry, for example, if a call doesn't go through. But what we use a lot is what I call a stateful retry, because probably it's not just a network hiccup for a couple of milliseconds, but the service is whatever down, redeployed for a couple of minutes. And then it would be still, in this case, a very good design that you clarify that within the payment. Because then you probably retry for a couple of minutes or even hours until it's done. Then the order service don't have to bother about it. And that's a much better design. There's even something harder to think about here. We have these distributed systems, and there is one really, really ugly characteristic of distributed systems. So if you do a call from, like, let's say the payment service to your credit card service. So the payment service is the client, the credit card is the provider. If you do the call and you get a network error, you have no idea which of these three failure scenarios have happened. So the first could be you never reached the service provider because the network gave up before. You probably reached it, but then it exploded for whatever reason, and you have no idea if that committed its transaction or not. Or it probably did everything, and the response got lost. And it's the same thing if you don't do REST communication. If you do messaging, then probably you never get a response message, and you have no idea which of the three things happened. That means whenever you do something like this, you call the credit card provider, probably even retry it, and then at some point in time, you you normally give up. You say, okay, this is not going to work for whatever reason. But in this case, you probably collected money from the credit card. You have no idea about that. You cannot know. So you have to think about these kind of scenarios. In some use cases, ignorance is okay. Payment is typically a bit more sensible. For some companies, I know it's also okay, but normally you don't do that. Normally you don't charge. I mean, you want to be consistent about what you charge the customer and what you send him. So in this case, you also have to make up your mind what should happen in that case. So if you say, okay, the payment fails because network problems, you probably still should do something about it, like checking if it was charged and then refunded, probably send a cancellation message over. That depends a bit on the API design back there. But the important thing is you have to do something about it. And again, it has to be, it has to be stateful. Because, I mean, if it was not available when charging the credit card, it's probably the service is also not available when you want to cancel it, want to refund it. Okay. So there are a lot of use cases for these kind of stateful things. Talking about this example brings me to my favorite topic. I hope you still can follow it. I know it's a lot of information in like very short time, but I hope you get through that. But now my favorite topic, where I have a completely own talk on it, I called it Lost in Transaction. And it's about consistency, because this is already a bit about consistency. So like once upon a time, you probably remember that, where we had like asset transactions, where you said like begin transaction, do a couple of things, and then commit or rollback. You still have that in this nice little hut, right? Because there you probably talk to one database, then it's very easy to have these kind of asset guarantees. But in distributed systems, you don't have that. So we cannot make like an asset transaction over this. We cannot. And there are normally some people in the room. Does anybody use two-phase commit or remote transaction, distributed transaction, two-phase commit, XA, three-phase commit, something like that? A couple of them. Who is happy with that? Oh, 1, 2. That's more than usual. There's an awesome paper. I totally recommend that paper. It's from 2007, but it's still very, very up to date. From Pat Helland. Pat Helland is one of the really distributed systems. Let's say, what's the English word for that? I forgot. But it's really a big guy in the US for that. He worked at Amazon when he wrote that paper. He also worked at Microsoft for some time now. He works at Salesforce. And he wrote about life beyond distributed transactions. And that's a good paper where he describes why these kind of distributed transactions, like asset transactions in a distributed systems, don't really work. They don't scale. It's nothing which you want to use. If you want to know why, probably read the paper. I normally, in the talk, I reduce it to my favorite quote from it, which is grown-ups don't use distributed transactions. So I wouldn't count on distributed transactions too much, actually. But we still have that requirement. We have the requirement that we do like 2 or 3 things in a row, and we want to have an all or nothing semantics, all happen or nothing. So how do we do that? And one of the, not the only, but very common strategy is so-called compensation. And compensation works like this. You say, okay, I have these activities. So let's, I extended the example. The first thing I do whenever I collect payment is that I check if the customer has credit on his account. If that's true, I just deduct some money from it. And then I check if I have to collect some additional money. Yeah, probably then I charge the credit card for the rest. And now assume there is an error with the credit card. Now I already deducted some money here. So I have to make sure I give him back that money because I raise a payment failed event. And that's the thing. So this is a so-called compensating action. I restore that. It's semantically undo. And BPMN, for example, can do that in the language. So I can define for every activity like this one, I can define that there is an undo activity, a compensating activity. And the workflow engine can make sure that if that activity was executed successfully in the past, that the compensation activity will be executed. And again, it's stateful. So if it's a REST call and the peer is not available, you can retry. So it's a very, very good way of introducing this kind of consistency there. It's also probably known as the saga pattern. A lot of people nowadays know the saga pattern. It starts to get famous, which is a good thing because I think it's a very, very important pattern in distributed systems overall. Okay, so one way of implementing the Saga pattern could be such a BPMN workflow. Not the only again, but there's another talk on that. If you want to discuss that, ask me later on. So that's compensation and BPMN. One thing, by the way, we start to accept, and that's a very important thing in distributed systems, we start to accept that we basically relax the consistency requirements. So like in the middle, when I'm here, like I haven't charged the credit card because it's probably not available at the moment, but I deducted some money from the customer account, that's an inconsistent state. So we violate the isolation property of asset. He has less money on the account, but he hasn't got anything for it yet. It's an inconsistency, but we have to get used to these kind of inconsistencies. They will be really normal for future use cases. Otherwise, we cannot handle that complexity at all anymore. So that's important. So that's also when you're like eventual consistency is a lot about these kind of things. Okay, awesome. I talked about that Saga pattern. I talked about like stateful retrying, a couple of things you can do with these state machines. And normally what people start asking me is like, but I want to solve like, let's say, technical problems there, which I just have as a developer. Do you really want to use these graphical models? I personally have no idea why people hate graphical models, but it's really statistically evident that developers seem to do that. Probably also because whatever, UML, MDA, bad experience. I have no idea, but I have an idea, but I still don't understand it. And the normal example I like doing here is the Saga pattern. That's what I said. It's quite famous. So you find a lot of articles around that. One article, which is a quite good article actually, from Clemens Fasters. He works at Microsoft still, and he wrote that quite a while back actually. So it's relatively old, let's say, for IT standards. And he wrote the same, wrote about the typical example, like I want to book a car, book a hotel, book a flight. If the flight goes nuts, I have to undo the other things. So that's the typical example. I also have that in code in BPMN if you want to compare that. But the interesting part, why I want to show that here, is that if you look at the blog post, that's the blog post, and it actually even goes on. If you look into the blog post, what he basically wants to describe is how he implemented the Saga pattern. That's the content of that blog post. But what does he start with? Obviously the picture. Otherwise you don't understand what he's talking about in the rest of the pages. And the thing is, the picture is, as he works at Microsoft, I think it's done in PowerPoint or whatever it is, but it's like a dead thing. It's probably outdated before he finished the blog post. And that's the thing. You need the pictures in order to understand things, and things like compensation, or probably even like stateful retrying, or how long do I retry until I give up? Like, what's a good timing? These are business decisions. It's not a technical thing. So you have to discuss that with people, and then it's really a bad idea to bury everything in code from my experience. So I'm a huge fan of what I call biz DevOps around these kind of workflow models. I don't want to walk you through all of that. I blogged about that, but just give you a couple of highlights. Like, for example, what we did at a couple of projects is like, this is a test case run. So if we run one test case, we render that image, and we know exactly what was the current path on the test. And if there was an error, like an exception or whatever, we also know where that happened. And that helps a lot also the developer to understand where they currently have a problem. It's everything about what's called, Rücker has a great book about that, living documentation. So this is not a picture you have in PowerPoint and it's outdated. It's the code, it's running. You are sure it's exactly what's running in production. So that's awesome. It's readable by different stakeholders. It can be used for operations. So if you have like typical BPMN workflow tools, they have some kind of UI where you can look into that. Like, for example, the charging of the credit card, there are 317 errors. I can drill into that, look into the error codes, look into the data, probably can probably fix it and retry it, or whatever I need to do, and that very often without looking into too much of the code. So that could be like an operations role, or it can get statistics from it, or whatever. So there are a lot of things what I can do around these kind of things, which are really, really, really awesome. I definitely like that quote from Jimmy. I'm from the US, so he's from 24 Hour Fitness. That's one of the biggest fitness companies in the US, and they run. You can see that like in the small pictures down up there. If you can read it, like 29 million of instances per day, whatever that is, and 190 workflow instances, workflow definitions like models. So they run a lot of BPMN on the different things I just talked about today. And he said, okay, and he's a technical guy. You probably can spot that by the clothing. So he's a technical guy, and he really loved that the first time they started to understand what they're really doing there, and it's not buried down somewhere in code. And I think that's really, really valuable. Going back to my initial example, there's still one really important thought, which is always good to put that in the last 4 minutes. So I hope you remember that, because that's really important. If you think about these kind of workflow models I just had and the kind of orchestration logic, so basically what I do is I implement orchestration logic by these kind of workflow models because they're probably long running, because I have to have that state handling. That's what I do there. It's not a central thing. A lot of people still think, okay, then I need that kind of huge workflow engine running somewhere. No, you don't have to. You can run it if that has an advantage, but you don't have to. So we have quite some customers who run this kind of workflow engine as part of one service. And then, for example, the order up there, the order just has the order service, like the overall workflow. And the important thought here is that it's not a God service. It doesn't have any details about payment. It doesn't care about credit cards or timing or how this is handled in detail, because that's part of the payment. I don't care about that in order, but I do care about that I'm waiting for the payment, right? And that's a good way of cutting these kind of things. So it's not like a monolithic thing. It's nothing central. And then it can distribute the logic quite natural. And that's very powerful. That's really very powerful. Okay, awesome. If you're now thinking about, okay, but how do you do that? How do you run that engine as part of one service? How can I imagine that? I don't go into technical details, actually, because of the timing. Ask me later on. I also have a blog post on that. So how can you run workflow engines? It depends very much on your environment, actually. So just to give you like 2 or 3 examples, very high-level pictures, actually. So you could run, if you're in Java, for example, you could run like a Spring Boot application running also the engine really as a library as part of your service. If you're fancy more like Java Enterprise, that's also possible. It looks a bit different. I heard that a lot of C# people or .NET people are here. Then it's typically like you run the workflow engine as kind of an own thing, like an own broker, an own Docker container, whatever you're up to. And then you're talking to it remotely via REST. And then you normally plug in like a client library. And the code within the service still looks a bit like what I showed on the slide earlier on. And then if you have different services, you just run that multiple times, if you fancy it. And then you have complete isolation as you want to have it in microservices normally. Awesome. So like as a summary, that I personally, I mean, that's what I said. I'm opinionated and very enthusiastic about workflow engines. But I think they're awesome. And I saw a lot of projects reinventing things just because they're afraid of introducing that. And I think that's a really bad idea. Okay, and if you want to have like the reality check, so I started with the Zalando, and if I look at Zalando, what they're doing is kind of like this. So they're using BPMN workflows in order to control the order fulfillment process, but only like the overall order fulfillment. And then they're using, in this case, Kafka underneath in order to steer the commands and the events and so on and so forth. They're doing quite a lot with that, like around 25 million orders per quarter. So that's quite a bit. If that, I know that were a lot of slides actually, and normally I'm the guy which loves diving into code, but I didn't have the real time for it. If you want to dive into code, so either approach me later on. I'm happy to walk you through. Otherwise, it's all on GitHub, and I have on GitHub the code which fits the slides, so everything is on there. I actually have even different versions of that order fulfillment process. So I have a choreographed version, a purely choreographed version using Kafka. I have a version which uses choreography and orchestration based on Kafka. And I also have these kind of REST things I showed you earlier with the retrying. And I have them in Java, C# and a couple of things in Golang. So it's probably worth to have a look in there. And then you should be pretty much safe for that. So we skip that. That doesn't matter that much. So as a summary, events decrease coupling. There are good use cases for that, but be aware there are also use cases where you need to orchestrate, where you need this kind of commanding. Okay. If you have these use cases, do it. And if it's stateful, if it's long running, then use proper technology in order to do that. There is proper technology out there. That's all I have. Thank you very much. And I don't want to actually stand between you and the lunch break. So thank you very much. These are the references and the links. If you have any questions, approach me later on. Thank you very much.